Good morning, everyone. Welcome. Thank you for coming. Thank you all for coming. Stakeholder meeting is very important. We want to start the day here by having a presentation on volcanoes, hazards, and futurevolc. And I'm the coordinator for the futurevolc project. We are working with volcanoes and hazards, and we use Iceland as a laboratory. So Iceland is located on the Mid-Atlantic Ridge. There are the North American plate and Eurasian plates that are spreading at a rate of about 2 centimeters per year, comparable to the rate of the growth of your fingernails. And we have a plate boundary. We have volcanic systems that have fissure swarms, that have central volcanoes, and calderas, shown in red here. And the most recent activity has been here in Iceland. Bárðarbunga was active 2014 to 2015, and its fissure swarm here towards the north. The most famous volcano in Iceland is Eyjafjallajökull, 2010, because of the closure of the airspace. And that is why we have this project, because Europe and the world found it was not very well prepared for explosive eruptions. In volcanology, we try to understand what is happening inside volcanoes. We try to understand the anatomy of volcanoes. And sometimes what happens is very complicated. We have various instruments we can put on the surface to try to figure out what is happening inside the ground. And that Eyjafjallajökull, it was almost more than about 2 decades of activity prior to the eruption in 2010. So one of the goals is to try to better understand what happens inside volcano. In Eyjafjallajökull there were 2 intrusive periods in 94 and 99, and then a 3-month-long activity period of complicated magma movements inside the volcano prior to the eruption. Why Eyjafjallajökull? It was the closure of the airspace, and that brings us to hazards. Globally, what is most worrisome is the fallout of ash over long distances, and at local in local surroundings next to volcanoes. It is of course the tephra fallout next to the volcanoes that can cause problems for people, and that is what we have been worrying about here in Iceland. The other types of hazard include, for example, volcanic gas. In the eruption 2014 to 15 at Hólahraun, this was a big issue. The SO2 pollution that travels over long distances and can cross oceans and country boundaries is so important. We have lava flow hazards that can be studied on the ground by observing how lava is flowing, but also from satellites, and there is a lot of information from satellites. Synthetic aperture radar images, this example from the Cosmos Skymet satellite of the Italian Space Agency, has been, these kind of data have been very important here in Iceland to monitor activity. And we have other types. In Iceland, sudden outburst floods or jökulhlaups during subglacial eruptions are important. Faulting and fracturing, very relevant in some areas. For example, here close to Reykjavik, our capital. And then there can be tsunamis if there's a collapse of mountains into the ocean or into caldera lakes. And because of these hazards and the fact that Europe was not well prepared for long-range transport of ash and gas towards Europe, a group of researchers came together and formed a consortium, the futurevolc consortium. We have 26 partners from 26 different institutions from 10 European countries, And there are more than 100 researchers involved in this project, actively carrying out research. The project got funding from the European Commission, the framework program 7, environment part of it, to focus on this special topic, long-term monitoring, experiment in geologically active regions of Europe prone to natural hazards, the supersite concept. And it was very important here in Iceland that we joined efforts, University of Iceland and the Icelandic Meteorological Office. We are leading this project jointly. By doing that, we could ensure the appropriate and sufficient leadership for this area. We are studying a wide area, so it's not a one volcano, and we set actually 4 volcanoes as a special focus of this project, and one of them erupted last winter, Orðabunga. So in the project we are trying to understand both magma moving inside the ground and how eruption plumes affect us and all the basically the whole phenomena of volcano anatomy and then how eruptive material is distributed. We have been going on for 3 years. We end next spring this project. There's an open data policy, and the full name is European Volcanological Supersite in Iceland, a monitoring system and network for the future. So we were trying to understand how we can combine efforts, how we can combine many researchers and monitoring institutions to provide effective advice and information on the hazards. And we have links, international links. GEO, Group on Earth Observation, is a voluntary partnership of governments and organizations for Earth observations. And the European Commission is very active in this, and one of the goals is to create something called Global Earth Observation System of Systems that is really coherent manner to observe the Earth, and within that we have the supersites, and our project then received funding from the European Commission to work on the Iceland supersite. An important complementary project is EPOS, the European Plate Observing System, that is to integrate research infrastructure and e-science for data and observatories on earthquakes, volcanoes, surface dynamics and tectonics. And we set out with objectives that in short can be explained as to establish an innovative volcano monitoring system and strategy, develop new methods and instrumentation, advance scientific understanding, and improve information from scientists to civil protection authorities, that is stakeholders. Therefore, this meeting, our stakeholder meeting, is important so you can understand what has been going on in this project. And it's a big project with these 26 partners, so it is divided up into different units, and they are all important. 10 work packages in the project that touch up on different items, database, communications, the past volcanic activity, ways to track magma in the crust, understand what happens just prior to eruptions, estimating the amount of material that is coming out of volcanoes, and how this material is distributed. And we need to demonstrate this consortium is a good approach, and we need to disseminate our results. And to get information on the project, we have a webpage, futurevolc.hi.is, general information. And as this project is designed, a European project, we produce many reports that are called deliverables that are found on this website on the project under each work package. So if you have a special interest in any work package, you can go to the website, go on the project, and find reports. And an important part of the project is information on the web. There's another website at the Icelandic Meteorological Office that we will hear more about on catalogue of Icelandic volcanoes and a data portal for data on Icelandic volcanoes, open access data. So some of the results include the data hub and catalogue of Icelandic volcanoes. There has been installation of new and coordinated monitoring equipment around target volcanoes. And this collaboration with the space agencies, Committee on Earth Observing Satellites, CEOS, has been important. And we have Icelandic volcanoes designated as a permanent geohazard super site. There has been effort on the original goal to study better eruption plumes and ash fallout, and that includes installation to detect better plumes and also development of algorithms to understand plumes better. There has been innovation, for example, development of instrument to automatically measure ash fallout from plume, the amount of ash and the particle size distribution. There's been improvement in communication procedures and protocols. And then the most recent eruptive activity has given us opportunities. So there have been many opportunities provided by the Bárðarbunga volcano. This eruption came at a good time in the project, in the sense that it was sort of in the middle of the project that this eruption started. It is rare for projects to be able to prepare for an event, then an event comes. Maybe not exactly the event we were planning for. It was the largest effusive lava eruption in Iceland since 1783, and 6-month-long duration. And it was preceded, importantly, by major unrest, including seismic activity and ground deformation, as magma was traveling in the crust. And associated with that, we witnessed a slow collapse of the Bárðarbunga caldera, subsidence of over 60 meters at the caldera. And these events and associated events have been studied in the project. For example, the unrest, where there was a magma-filled crack that formed from the Bárðarbunga caldera out to the eruptive site here. So Bárðarbunga is completely ice-covered volcano. We were lucky that magma flowed in the subsurface out towards an area outside the ice cap, and there we had an eruption, and we had fracturing. And we had this large lava flow forming that covers an area comparable to the size of Manhattan, with an average thickness of lava of about 15 meters. This activity, we could put in use results from the futurevolc project during this activity in the form that it complemented other efforts that are ongoing here in Iceland. Of course, lots of resources from Icelandic authorities towards this activity, but we had collaborative venues in place. We had actually some instruments on the ground before the activity, and we contributed to daily meetings with civil protection and authorities to try to evaluate the situation. So this unrest period is a good example where sort of joint interpretation of ground-based data, space data is used in a timely manner, providing advice to civil protection and authorities. And we have managed to, in addition to these reports that are produced and on the web, we have a good publication record already from the project in international journal, including just here a selection of papers that are in high-level journals that receive the widest attention. That includes a paper on the segmented lateral dike growth in the rifting event at Bárðarbunga, and it includes papers in Nature Geoscience on earthquake activity, and also the correlation of ground deformation and plume activity, where we could see a correlation where we could interpret together ground deformation data, how much movements were occurring on a volcano in the subsurface, and relate that to activity of the eruption plume. And the project has been evaluated. The European Commission has prepared a report on EU-funded project illustrating European research and innovation excellence. And futurevolc is taken as one example of that, that we have contributed to increasing the understanding of volcanic eruptions. Both here in Iceland, at the Icelandic volcanoes, the monitoring has been improved, but in general also we understand the processes better in general. And this is important for us here in Iceland, stakeholders, authorities, civil protection. It is also internationally something we look at, because futurevolc research will feed into the group on Earth observations, part of Europe's contribution to a global effort to improve forecasts on volcanic activity. And I think I will stop here, but discussions would be good. Thank you.